Well, thanks for taking the time this morning to join. So it's good to see Derek, just met you before, and Cameron Clark and others. So today we're talking about vegetation options for resilience in pastoral hill country, specifically in New Zealand. So I'd like to really thank the co-authors that have been involved in this. Grant Douglas, who used to be involved with ag research, he's got a really good knowledge of woody vegetation and has led the part of the paper on woody options for hill country. Mike Dodd, he's been excellent with his knowledge of farm systems and contributing there. And Karen Mueller, who's from plant and food research, has a background with soils and environmental science. So it's a really good team to work with, very different skills and knowledge base, and that's been very helpful for this paper. So for those of you that aren't familiar with New Zealand, now, the map there of different sort of landforms, and you can see looking at the dark green, there's quite a lot of hill country. It's about 40% of New Zealand's land area. And on that map, it's simply broken down into hill country, mountainous kind of land, which a lot of that non-pastoral land is actually mountains, then your flash and rolling land. So you can see in the North Island in particular, there's a lot of hill country area, a lot of beef and sheep farming going on in these areas, and they're faced with many challenges. So it's these sort of areas that we're looking for options to help the land managers to improve the resilience of their pastures. We're usually talking about land that's above 15, 20 degree slope. This map is based on above 15 degrees, but often we're talking about above 20 degrees. So that's a sort of slope where you can no longer get machinery on the land, which of course reduces the number of options that you have available. Just a little bit in terms of climate, there's a map here produced by NIWA. The main point here is just incredibly variable, from quite wet to quite dry. And on top of that, within farms, there can be a massive variation between different areas on the farms, different aspects, different slopes, different soil, different topography. So it makes it quite difficult for farmers to manage quite diverse landscapes. I've got a picture here of a hill country farm in the upper North Island in Waikato, which is where we live and one of the farms where we've been working. So at the back, for example, you've got a paddock that's 30 degree slope, and the front you've got the rolling land, and just over a 5-6 month period, just the change there in terms of the pastures. So quite summer dry, maybe not as bad currently as what's happening in the western part of the United States, but it still presents challenges for farmers in terms of the feed supply. Just a graphic here, just looking at drought over the last 20 years or so. You can see very often there have been some extremely dry years where there may be 3-4 months of a lot of water deficit. And then, yeah, quite a range there. So that's the sort of situation that we're working with and wanting to work with the landowners to provide them options to make their pastures more resilient. Now, in the paper, we've focused on 2, and today I'll just discuss a subset of what's in the paper. So the first one is looking at working with the pastures that are there, and particularly looking at deferred grazing. Deferred grazing is something that is quite old, but we've been able to do some more of the science, looking at the mechanisms and how it works and how it might fit into the farm system. The other is introducing woody species as fodder. So woody species have a number of benefits, but we were particularly interested in, can we increase the vegetation resource in the vertical plane, as well be strengthening the soil through the extensive root network, and using that to increase the resilience of the hill country resource. So I'll focus now firstly on the herbaceous species and on the deferred grazing. So in terms of definitions, that's quite important, because in the literature and in different countries, people are talking about deferred grazing at different time periods and for different reasons. So in terms of definitions, the assumption here is that we have a perennial pasture base that we are removing livestock from grazing the area in the middle of spring and reintroducing the livestock at the end of summer or early autumn. So we're looking at 3 to 4 months. Now, there has been work done in New Zealand and elsewhere on shorter periods of time that was still from mid-spring, but in this case, just till midsummer. Now, the whole thinking here around all this, in terms of the science behind it, is to be working with the plant during its reproductive phase. If you look at the past paradigm in New Zealand, we've been very much focused on the pasture quality for obvious reasons in terms of livestock performance. So this has meant that we have focused on keeping the pastures with as much green leaf as possible, which is fantastic for livestock production. However, it is possible that through doing this and not allowing the plant to complete its reproductive cycle, that we are having some quite negative impacts on resilience. And what we're suggesting is that there are times when you can defer pastures, not all the paddocks in the farm, of course, but a certain proportion of the farm, and that this has implications for profitability at farm scale, as well as for resilience of the pastures that have been deferred. Now, in the paper, but not so much here, because it's going to be focusing on a full deferred period, it has been shown that there are benefits for tiller population recovery and growth from a short deferred period. The research has been done there. It's actually been in less stressful environments, more on flat and rolling land and not in hill country. For work we've done, it appears that we are better to go for a full deferred period in hill country, where there are more severe stresses and potentially competition with other grass species, that if you do a shorter period, it's not going to be as beneficial for the species that you are wanting to encourage. Now, a lot of the hill country pastures may have been sown or oversown with ryegrass, say aerially, or even going back historically, people just hand seeding or possibly seed that's coming through animals. So ryegrass, with the research we were doing in the Upper North Island, was the species we were most interested in. And of course, the clovers are absolutely critical. In Australian situations, it might be species such as cocksfoot or phalaris or native perennial grasses. And there'd be a range of perennial species for which this sort of work may be relevant in other overseas communities. However, the work that we've been doing has been focused on ryegrass, although other work has been done on cocksfoot and phalaris and, so I say, native perennials. So when we're talking about resilience of that pasture, we're very much focused on those sort of desirable species and on the legumes. So going on in this study, we'll just focus on the full deferred period. So talking for us about summer wet and summer dry, these are some of the areas where we've worked. So the picture on the left on the bottom shows cattle grazing off a deferred pasture in a summer wet situation. So you see there's still quite a lot of green material there, while on the right it's summer dry, and you can see it's actually quite poor quality forage by the end of the summer, but then not just the deferred pastures poor forage, but the whole paddock was dry. Now we're most interested in what's happening with the tillering of the plants. So we did work in the field, but we also looked in the glasshouse as well as what was happening with the carbohydrate reserves to understand what was happening with the energy flows and how and why plants were responding to the different grazing managements imposed. So I'll start first in terms of what we learned about tillering with the plants. So on the left, we've got the summer wet, and on the right, we've got the summer dry. On the left, we've got at the top a graph of the tiller densities of the plant. You can see it's deferred from where that grey bar is, from the middle of spring until towards the end of summer. You can see in the deferred pastures that there is an increase in the tiller densities, which was maintained for quite a number of months after the deferred period. And eventually, as after the deferred period, when it goes back into the traditional rotational grazing, that the gap closes and there's no longer a difference between deferred and grazed. On the right in the summer dry, you can also see that there is an increase in tiller density in the previously deferred pastures, but then it crashed a lot more quickly. We were interested to understand why this would be. And what we think might be going on is the different responses of the plant to the grazing exclusion in the summer wet to the summer dry. In the summer wet period, where it was conducive for ryegrass growth, we found that there was a lot of regrowth tillering after the summer, and that these tillers from the existing plants contributed to the increased tiller populations. You can see that in the graph with the bottom left. The white part of the bar, which is the seedlings, there was a very small contribution of seedlings when it was measured. 2 grazings after the end of the deferred period. It was mainly tillers from existing plants. However, if you look at the bottom right there, you can see that the seedlings provided a much greater, much higher proportion of the total tillers that we measured. As you would be maybe aware, if you are trying to introduce seed into an existing perennial pasture, it's hard for these seeds to establish and reach maturity. There's a lot of competition going on, and a lot of these seedlings die. And that is why we think in a summer dry environment, if you are relying on reseeding as a mechanism from deferred grazing to increase the tiller populations, it's less likely to be beneficial over a longer period. It is more likely that most of the seedlings are going to die, and that you will more rapidly see the benefits from deferred grazing decline, and that the tiller populations will soon reach be similar to in the graze control. As in the summer wet, where it's from regrowth tillering, so you've got bigger, more densely tilled plants, we think it's more likely that that benefit will last for longer. Now that's ryegrass. Similar work with cocksfoot and phalaris in Australia there's been similar kind of results where the benefits for the deferring were from new tillers on existing plants rather than from the seedling recruitment. And traditionally, it's often thought that the reseeding is really important. We're not saying it's not, but we're saying we think that the regrowth tillering is going to be the better strategy to maintain higher tiller populations. Now, why is this tillering happening? We think that the increased carbohydrate that is built up in the plant during the grazing exclusion period is playing a critical role in driving all this regrowth tillering and the trends that you can see here. And I'll talk a little bit about that later on. But with this regrowth tillering is associated a large increase in the herbage production after the deferred period. Now, the farmers have noted this, and we're able to do some measurements to quantify this. So during the deferred period, you have the grasses becoming reproductive and starting to senesce, or the tillers. And this leads to a suppression in pasture growth in comparison to if it is rotationally grazed, for example, you've got vegetation being removed and you've got a lot of regrowth and it's staying green and leafy. So there's a suppression during the deferred period when it's been deferred. However, after the deferred period, you get a large surge in growth, which is consistent with the retillering and all the energy that's being stored up in the stubble and the base of the plant. It's just going into new regrowth. So the graph that we've got here is actually just showing how it's a change in the timing of the feed supply rather than the overall amount of feed produced that's been changed by the deferred grazing. Over, I think it was a 14, 16 month period, the total amount of feed produced was the same, or actually in some cases it was greater in deferred pastures in some of the experiments what we did. So if it's the same amount of feed produced, so what? What's that mean? If you're just simply changing the timing of your feed supply, is that of any benefit to the farmer? We think it is, based on some modelling that we've done and also from what they've told us it means in terms of the farm system. Firstly, you can get the rejuvenation of the deferred pasture, which is, we're thinking, useful in terms of pasture resilience. When it has been hit by stresses such as drought, heat stress, it enables the plants to recover and the desirable species to remain dominant. As well, there's a change in the time in the feed supply, so there's the feed bank at the end of summer. That means that livestock can feed on the deferred pastures as they're opened up. And this covers the ability to be increased during autumn on the other paddocks, so the pressure's taken on them, which can help set up the feed supply in spring. Now, the biggest benefit that translated into financial benefit for the farmers was actually the increased pasture quality in the remainder of the farm. So this is based on talking about quality, there's one thing here to look at though. The quality in the deferred pastures, the impact depended on whether it was a summer wet or the summer dry farm. Just thinking back to some of those slides where we looked at the pictures in the summer wet farm, at the end of the deferred period, the pasture that's being fed out is still relatively green and leafy and relatively high quality, but it's still not as good as one that's been rotationally grazed. So there you can see with a deferred pasture, there's still quite a drop in the quality in comparison to one that's been rotationally grazed over summer. On the summer dry with the drought, pasture quality is low wherever. The thing to see here is that relatively soon after it is brought back into the grazing round and the pastures are grazed, the quality does recover. We'll talk a little bit later on about the sort of livestock that you might need to graze off deferred pasture and to bring them, the paddocks back into a rotation and recover the pasture quality. So overall, if you're looking from a farm scale, you do have the reduction in pasture quality, but it recovers. And the benefits as we're talking about come from the rest of the farm and what's happening on the rest of the farm. So we chose one of the farms, we were doing some of the research, and in the FarmX model, removed 15% of it from grazing from mid-October to mid-Feb. Now we've talked about what happens during the deferred period, that there's a suppression in growth in the paddocks during the deferred and the regrowth after. The big impact came from what was happening in the other paddocks. By reducing the amount of feed that was available, it meant that the livestock had effectively a smaller area of land to graze, and they were able to keep up with the spring flush of feed that typically happens in hill country farms when the feed supply exceeds livestock demand. So by deferring, with this farm, the feed supply now met livestock demand by removing 15% of the paddocks from grazing. And by doing this, it meant that the grass was kept shorter, which meant it was of higher quality and resulted in increased livestock performance. In the model that we used with the case study farm is through the increase in the ewe and the lamb performance, and this resulted in increased farm growth margins by 8%. So we've covered on what's happening with the tiller populations when you defer a paddock, how this relates to herbage mass, what this means at a farm scale level, but there's also other implications of deferring, some of which we've measured and some of which we're speculating, would like to research, that can have implications for hill country. One of them was the ground cover and what this might mean for the environmental kind of benefits. There was significantly more ground cover on previously deferred pastures than on the rotationally grazed ones, which hadn't been deferred, on a number of occasions after the deferred period in both summer wet and in summer dry farms. This could have implications for nutrient losses and sediment loss. We don't know if it's just how much of an impact it will have and if it's agronomically significant. So that is something we would like to look at. Now, if you're wondering why there's more total ground cover, some of it is going to be from the breakdown of the plant material that's still there, and also higher tiller populations. So the total ground cover will comprise both living and some dead plant material. There may be implications for control of undesirable weedy species. You can see a picture here of a paddock. The left side was deferred and the right side was not deferred over the late spring, summer. So all that clumpy stuff you can see in that picture is actually California thistle, Cirsium ovens. This is only one split paddock, so we're currently doing some replicated field work to see if this impact is repeatable and looking at some of the possible mechanisms that are driving it, but it is consistent with what you find in the literature. At the end of the deferred period, you're having maybe 3 to 4 tonnes of dry matter that's accumulated. It's a lot of competition for light and for resources. That's consistent with controlled studies with thistle. They've shown how neighbour competition can reduce thistle growth. The interesting thing is they're looking at that graph. In the deferred pasture, you can see with the thistle presence that was reduced at the end of the deferred period, and that this trend has continued on for well over a year. So it looks like there's potential for there to be a long-term suppression in thistle populations, and that possibly over a decade, it might be needed that the paddocks deferred several times just to help reduce those thistle populations to levels where they're not going to have a serious impact on the productivity of those pastures. So that's very much watch this space. We did find that the herbaceous species that are very prostrate, that they were significantly reduced at a number of field sites by the deferred grazing. And again, just thinking of the biomass buildup that you get during the deferred period, it's quite plausible that this is going to be happening. Now we've focused above ground. We did do work below ground looking at the soil structure. There were some short-term changes, but not a lot. And we were also quite interested in what's happening with the roots. We've tried to do some work out in the field, but it was such a hard drought, it's not even possible to get the corers in. But we would like to do more there. We had done some work in glass houses in 1 metre deep root tubes where we simulated what was happening out in the paddocks. So perennial ryegrass plants were either being trimmed when there were 2.5 to 3 new leaves to optimise the replenishment of water-soluble carbohydrate supplies and keep the plants in an optimal growth stage where there's lots of green leafy growth. Or else we didn't trim them from the middle of October right through till the end of summer, so from mid-spring through to end of summer. And we did multiple harvests to look at what was happening in the plant with the reserves, tillers, herbage mass, and root growth. And what was amazing was the impact on the roots. So on the left there, you can see the crowns of 3 of the ryegrass plants and the root mass in the top third, the middle third, and the bottom third of the root tube. So that's in just simulating rotational grazing with no deferred period. On the right, you can see this massive accumulation in root mass in all layers and then at depth. So we would expect in the paddock that there may be the same sort of pattern. To what extent it occurs, we've got no idea, and we think it's something that does require investigation. And even if there is effect, for how long does it last after the pasture goes back to standard rotational grazing? Is it something that is of interest, or is it something that actually has implications for carbon, for nutrients? But we don't know. It's something that we would like to look into. Or if you deferred for a longer period, but then you need to look at the impact on the quality and on the pastures. If you deferred for 2 summers running, so just normal standard grazing in between, but did it 2 years running, would that have more of an effect? Lots of questions that we'd love to look into. Now, I've spoken about the water-soluble carbohydrate. We were able to measure that in the leaves, the stubble, the crown, the roots. So you can see there in the right what in terms of the plant parts where we're talking about. And the main thing here was just the massive accumulation in reserves, twice as much than the leaf at the end of the simulated deferred period, and the stubble 3 times, the crown 5 times, the roots twice as much. So that cessation for grazing during that period has allowed a huge accumulation in those reserves. So if you think about the regrowth tillering after the end of the deferred period and the increase in herbage production, it makes sense and it all ties up. So there's things going on here within the plant that are allowing the rejuvenation of the deferred pasture, but through how that changes stock management has implications for the whole farm. So it has implications for the pasture resilience and recovery after drought, but it also has implications for farm systems resilience and giving the farmers tools that they can relatively easily integrate into difficult hill country situations and can better place them in terms of matching that livestock demand for feed and the feed supply. Just a few things that are critical for its success. We're assuming here that there is a spring surplus for the farmers to work with. If they are in systems where feed supply and livestock demand are already matched, this may not be a useful tool for them. Some of the farmers we know, because there's been quite a few droughts now over the last few years, it's just so unknown what the seasons will bring. To a certain extent, they will work to build up a little bit of a buffer ahead of livestock to intentionally diverse some pastures, just so they have those buffers there. That enables them to keep stock on safely rather than sell some of the stock that they'd rather use. But it's one tool amongst many, and in some situations it's not going to be an appropriate tool. In terms of what to graze the pastures off with to help remove a lot of the dead materials there and encourage a vegetative growth, we thought that pretty much you probably really needed cattle and you couldn't do it with sheep. However, a farmer there showed us, no, you can do it with sheep. And the picture there near the start, that steep hill country, 30-degree slope, and the rolling country, he actually was able to bring the deferred pasture back to good quality pasture just using sheep, mod stocking and using temporary fencing to over several days to graze off some of the paddocks. Obviously, care does need to be taken with a stock class where the hills are steep and keeping in mind rainfall events, storms, things like that. Given that we're talking about a number of paddocks, not the whole farm, there's flexibility for the farmers with when they're grazing it off and to be mindful of the weather. So again, just emphasising some of the key messages. Benefits, we're seeing it as a tool for resilience, for recovery, for being able to withstand and recover from stresses, particularly summer dry. Drought feed in the bank at the end of the summer. Maintaining pasture quality over the whole farm and through that increasing whole farm profitability. So that's the first strategy. The second one was woody species for fodder. Unfortunately, Grant Douglas wasn't able to present this today, but I'll present it on his behalf. But do look at the paper for those of you that are interested in this area. In particular, I will just mention a table in the paper that Grant has done, and I'm just actually turning to the paper here in front of me. Page 10, page 11, Grant has looked at a number of different woody species that have relevance for New Zealand hill country. With the literature that's available, which is actually often quite sparse, he's gone and looked at the environmental tolerances of the different species, at the drought, frost, tolerances to dampness, wind, salt spray, looked at the growth habits, growth rates, palatability, any mention of toxicities, tolerance to defoliation, weed risk, and seed availability. So there's that table there in the paper for those of you that are interested. So in terms of woody species, we're focused on fodder, but as you would be aware, there's many and multiple benefits of the woody species for the shade and the shelter. You can see there with the pictures there on the right, middle one, that's tagasti. So some lambs there. It's like very good in harsh environments. It's the shelter, but as well, it's providing a bit of browse. Bees and birds, it's becoming quite useful to fill the gap in terms of the timing of the flowering for beekeepers in late winter flowering. That's again the tagasti. Building up soil organic matter through the recycling of the nutrients. Vista enhancement, for a lot of farmers, just having those pockets of plantings gives them great satisfaction. Of course, the soil stabilisation in terms of the good network of the roots that are going to be able to stabilise the soil so much more than any pasture plants will. Now, in New Zealand, there's been quite a bit of interest in exotic species since before the 70s, and that's been the research there has been done on a range of sites and on a range of land classes. More recently, there's been interest in native species for fodder, and there has not been much work done on this at all, but there's a lot more interest. Some of the European settlers had accounts of using native species for livestock, and one of them, for example, I think was known as cow leaf. In terms of some of the exotic woody species, I'll just let you cast your eyes over that list. It might be that in the countries where you are, that those species are being used. And together, it may, with all the different traits, that they've got potential to be used in quite a number of different locations. In terms of the native species, these are some of the species that we're interested in. They're a lot slower to establish, and we just don't know the basics in terms of how to establishment and manage them for fodder on hill country. We're trying a few different methods. On the left, for example, you can see a newly planted tree surrounded by that wire cage, which actually has quite pointy ends where the wires are protruding outwards. So the intent here is that the trees will be able to grow up, the leafy material will grow through the mesh and can be grazed, but with the pointy ends of the wire, that it will stop the cattle from going too close and causing damage to the trees. Now, this is new, so I can't tell you how it's going, but that land there's, I think that's about a 30-degree slope. In the middle here, there's some other methods being trialled, and that again is with tagasti. So the aim here is for it to allow the trees to provide some browse, because the livestock are able to access the leafy vegetation at the top of the tree guard, but the tree will continue to grow. And from this, we're more looking at the roles in terms of soil stabilisation through an extensive root network, with the browse being secondary. And on the right, you can see a closely trimmed shrub, and what we are hoping is that we could have bands or plantings of these trees and hillsides with direct grazing. This again is tagasti, the one in the middle and the one on the right. Now it's has been used quite successfully in Western Australia. There they can mechanically harvest it. Here we can't. You can see from these slopes, we're talking quite difficult land, and so we're needing techniques that are very different. What would be awesome is somehow we could get cost-effective solar-powered tree guards that would allow the plants for the foliage to grow through and to be consumed while protecting the plants, like the trees, from being ring-barked. At the moment, that is not possible because it's not cost-effective. The technology's there, but that is a sort of protection that could possibly allow spaced plantings of a whole range of trees to be successfully integrated into pasture hill systems. Again, focusing on tagasti, we wanted to look at what pasture could you grow when you've got a pasture tree system for steep, particularly north-facing hill slopes in the case of tagasti. So we were looking purely at what pasture species would thrive best in this environment. So we weren't so much interested in grazing because this was spaced plants. So a spaced plant situation, if you have livestock grazing them, the clovers, the legumes are going to just get slaughtered. We wanted to see how well they grew, what their production potential was in open pasture or under the canopy of a tagasti tree. So we had 9 different species and different shading regimes: open, light shade towards the edge of that, like the perimeter of the trees, or right underneath them. Now, on average, this isn't looking at interactions, it was up to 75% reduction in production of the space plants in the heavy shade. You can see the light's intermediate. and in comparison to the open pasture. And in terms of which species grew the best, are the ones that we assessed, cocksfoot came out way ahead. So that's modern cultivars. I understand in America it's sometimes known as orchard grass. I thought, well, that's quite appropriate. And microlina was another grass that we tried. That's a native in New Zealand, native grass. It's very persistent, great ground grabber, but not very productive. And in terms of commercial production, it's quite difficult to harvest the seed. And it's possibly something that you wouldn't look at for productive hill country systems in comparison to something like cocksfoot. In terms of the legumes, lotus went quite well, but it's not something, even though it went well, we're not actually sure how you could effectively integrate it into a pasture tree system. Now, in this case, the subclovers were not producing as well, but other work shows that they can produce well and can be very well integrated with cocksfoot. There are some, and I think there is some variation in cultivars in terms of shade tolerance. We think that actually the cocksfoot and subclover for dry, steep hill country systems could be the way to go. And we would be suggesting that farmers establish desirable pasture species first and then introduce the trees into that system. So in summary, from the two different techniques, two different areas we've looked at working with the herbaceous species that are there, and in particular, simply deferred grazing, something that's very old, but the critical things around when to open, when to shut the gate, when do you remove your livestock, and when do you reintroduce them. That's something there that we need to share with farmers and learn from farmers as well in terms of when those key times are and why, just to pass on what we've been learning about the energy reserves and the tillering. Because if they've got that information, they can then decide how to best fit that into their systems. And also some of the information on what it means for the pasture regrowth, the farm max modelling, all those sort of things are really useful. We need to do research in terms of nutrient losses through the runoff and leaching. Because of the impact on the roots, on the ground cover, we think there could be benefits there, but we don't know. In terms of woody species, so much work there needs to be done, and it's often quite difficult because to look at the root systems of trees on hillsides is difficult, and it takes a lot of time. And as you know, often funding is short-term rather than long-term. But we would love to look at some more of the implications of animal welfare, what it means for the reducing sediment loss and nutrients in the waterways, and particularly with the natives, what could be the role of some of the native species? How do we establish them and manage them? And going from that, how do we develop the pasture and the native woody forage systems for the hill country? Now, what's been presented today is from a number of different projects and been a number of people involved, and I'd just really like to highlight them and just thank them for their work. And thank you too for listening. I hope this has been useful.
Thanks for that, Katherine. That was really interesting. You covered a lot of information there. So we'll just crack on to the questions. I'll start off, and then if anyone has something they want to ask, if they just raise their hand or speak up, either is fine. So the first thing I wanted to ask you about was what sort of grazing pressure you use under the deferred grazing management.
Yes.
Does that have an impact, or like, you know, do you graze it hard and then sort of let it come away, or have you sort of looked at different management practices there to see whether that affects the response? Yes,
that's really important. I can't quite remember the stocking rates, but it was stocked heavily. Now, given that you're talking to 3 to 4 tonnes of dry matter easily at the end of the grazing period, sometimes farmers would remove it in the first grazing, but more likely it might take 2 grazings to be able to remove a lot of that material. And it's not all used. A lot of it's going to be trampled into the ground. In the FarmX modelling, we only assume 50% of the utilisation.
Oh, well,
so does that answer? Yeah. So you're still getting the overall farm profitability benefits, even despite a lot of that forage not being good quality and a lot of it not actually being utilised.
So have you looked at how that impacts organic matter in the soil? Because I imagine a lot more trampling would increase soil organic matter.
Yes. Yeah. Relatively short-term effects. There was some significant impacts there with the organic matter. There is more effect in some of the other research, for example, Mackay et al., who's worked at Ballantrae, that's a North Island summer wet hill country farm. So there have been changes. We had relatively little statistical power with ours, and it's something we want to look in further, but we also wonder if a longer deferred period may have greater benefits for some of those soil properties.
That's really interesting. So do you think then that we use rotational grazing too much in our pastoral systems? Do you think that even on flat and sort of rolling country that we could be using deferred grazing practices more often?
Cautiously, at times, yes. If it's flatland, of course, there's a whole range of other options that could be used in terms of cropping. So I say cautiously, I think it sometimes can be an option, thinking about the farmers we've worked with, when for a range of reasons they may not want to use cropping options or machinery. It could even be simply where those paddocks are in the farm. So there's all kind of, there's all those sort of things that come into it as well. And if it's flatter land, now assuming too the fertility is good, because we want to be encouraging productive high fertility species. We don't want to be encouraging low fertility species like brown top, and I didn't mention that. So assuming you have adequate fertility for the desirable species, you can get a massive regrowth and have good end of summer or autumn feed in flatter land that's been deferred. The steeper it gets, overall the production is going to be lower.
So I did want to ask you a little bit about whether you guys looked at the nutrient profiles of the when you mix woody species with herbaceous species. Did you find there was any sort of, did you actually look at how nutrient profiles were affected by different woody species? Or
in this case, with the natives, we haven't yet, because we're actually just getting them established. For the tagasti, yes, we have. Now there's some elements where it complemented quite well what's in the pastures. I can't remember what they are off the top of my head. The issue though with tagasti in terms of the nutrient regime is that it's got the, the tannins, which can affect the nutrient absorption in the gut. So although looks like it can be reasonably high energy values, and it's got some good minerals, they may not be used as well as what the actual values would suggest.
Yep,
at least it's not an earthquake.
Yeah. Yeah. So did you look at how like animals prefer different? Do they prefer different sort of species? Like if they're offered, say, cocksfoot versus tagasti, did they prefer either of those species, or is that something you've not covered yet?
Not yet. The one we were doing, we were trying to do one study in which they were grazed, and the ironic thing is they would not directly graze the tagasti. As soon as it was cut and dropped over the fence, they absolutely loved it, as causing great frustration. The person who we were working with, whose own livestock just normally absolutely loved it. So I think a little bit of training of livestock often for them to become familiar with new feeds is important. And there's some questions there down from June, is it?
One from John Fike actually is first. What concerns over invasivity of non-natives? So are there any concerns of,
That's so important. So in the table that Grant has put together, that is one of the things he's covered. And yes, there are issues. Tagasti, for example, itself, in some areas like Banks Peninsula, which is on the east coast of the South Island, a peninsula, it does grow on roadsides, and it's quite a lot. And there, it's almost, you could almost consider it, just to be careful. We've had concern expressed about planting it, for example, in shingle riverbeds, because it could grow very well there and form dense thickets. So that's a negative side. On the positive side, some of the regional councils are suggesting tagasti almost as a nurse sort of plant, because it's relatively short-lived, and that can provide a bit of cover for native species to grow, which are much longer-legged, and they'll replace the tagasti. given that it's not very frost tolerant, there's whole areas where it won't grow. And that applies to the other sort of plants too. We need to be very careful what we're introducing, where it's being planted, and because, yeah, the last thing we want to do is introduce something that's going to be very invasive.
Yeah, absolutely. And so there's another couple of questions from Juan. How cost effective is planting the woody species, and what about scale?
So it's cost effective. I think, what was it? It was a lot of work's been done on poplars and willows. And in New Zealand, it was a few dollars per plant more expensive than the poplar or than the poplars, taking the labour into account. The current system we've got that's relatively cheap has got fiberglass poles, the plastic wire mesh, and some sort of weed macker at the base, which means that you don't have to have the herbicide release in the same way, like you're just digging over that site. So that's reducing cost there. In terms of scale, definitely now there's hillsides being planted out. So yes, it can be scaled up, but it is still quite labour intensive. And I think in terms of scale, if we could develop something like a cost-effective solar-powered tree guard for hill country, the grazing becomes so much easier. Like, that's one of the main things I think that stopped it being expanded, because of needing to manage those trees carefully in the first few years, in particular with limiting cattle grazing and only having sheep. So if you're limiting cattle on steep hill country, there's real issues with pasture quality.
Anita,
Yeah.
can I ask a question?
Yeah, absolutely.
I'm a regional councillor at Environment Canterbury, standing in for Councillor Elizabeth McKenzie today. But just on a couple of things that you've talked about, it's all very interesting. Thanks very much. I'm concerned about a couple of things. Your research is ryegrass and mainly grass is the sort of thing that's sort of standard pasture mixtures. Have you looked at experimenting with more multiple variations in terms of a lot more enrichment of those pastures? That's one question. The other thing is planting trees on slopes that are erodible and forcing them to do that seems counter to good landscape management, if you like. Is the situation really a question of destocking and extensive grazing and not having so many animals trying to eat pasture on steep slopes? Either retiring them, using New Zealand native species, and actually diversifying on those hill slopes. We have kanuka, manuka, honey, other sorts of crops. So that's my question, is that you're kind of threshing hill slopes, and why?
To start with that one first, look, definitely horses for courses. There's going to be some hill sites where it's just not appropriate to have livestock. And the farmers we're talking about that are working with the trees on steep hill slopes, some of it they're also, where it's not appropriate, they're letting revert to kanuka and manuka and are managing that or are planting out. So totally horses for courses, and in some places livestock are not appropriate. So it's looking at for grazing is still appropriate, and it may be that it's still appropriate to reduce the stocking rate and have trees. So both can still go together quite well. Now, I don't have enough of a land management background or soil science background to be able to respond here, but and I'm working with Peter Manson quite closely from Hawke's Bay Regional Council in this, and Grant Douglas, and they, if they were here, unfortunately, could probably respond to that with greater knowledge than me. But yes, definitely, it's not that you're trying to farm in areas that shouldn't be, but where areas that are appropriate and suitable for farming, to be reducing the risk and to be stocking appropriately.